Good. Hello, everybody. How's it going? Excellent. My name is Joe Davenport, Director of Business Development for Hyperconverged Solutions. That's our Ross Ultrix and OpenGear product lines. And I'm here to talk about the ins and outs of today's signal transport options. I thought about naming this When Do I Pee? But I thought that might not quite work so well, so we went with this title. So a lot of people are migrating to 4K, maybe even 8K. People are doing facility refreshes. So a lot of people are asking, do I double down on SDI? Do I commit to IP? Maybe I do a hybrid. What we're seeing from the manufacturer side is even SDI-centric facilities today are doing some version of hybrid. And there's a whole bunch of IP standards to choose from. So we're going to take a fairly high-level view of a lot of those IP transports that are available today. This is not going to be getting super into the weeds here, so I am more of a salesperson, so please keep that in mind when we start talking about some of the things here. And then we're going to go through a couple comparisons, and then just talk about a few examples of when to use different types of transports. As people are thinking about this, they're thinking about what kind of workflow is this going to be for me? So like a 2110 workflow is a lot different than maybe an NDI workflow or your traditional SDI workflow. What kind of technical support? That's a big deal, right? Do I have the networking staff to be able to support a 2110 solution or even an NDI solution? How do I do interopt, right? How do I get SDI to 2110 or NDI or SRT or what other acronym you can think of? Will it do the job that I need it to do? If I'm used to plugging in a BNC cable to show a piece of video on a monitor, is that going to work the same when I start using networking skills for this? Will it save me money? That's always a big thing, right? IP may or may not save you money. So, and of course, what does it cost to do these things? So we'll look at some of those things. We've got alphabet soup here, right? Probably a lot of you guys have seen a lot of these. Maybe some are new to you, but this is what we're dealing with today. All the different types of flavors for different purposes. It's not just a piece of coax anymore. So we've got SMPTE 2110 is the top dog when it comes to IP transport. It's neighbors of NDI and IPMX, and Dante AV to some degree. And then in the more like WAN and remote side of things, SRT, RIST, WebRTC as well. So there's a handful of things that we're going to go through here and hopefully give you guys a little bit of insight on some of these different types of transports and go through things. So let's sort it out. All right, so 2110, we'll start with that. It's a little bit different than all the other ones we're going to talk about in that all the essences in the signal are actually separate streams. So you've got video flow as separate from audio flow, which is separate from ancillary data. These all travel in different ways compared to the other side of things. So we're showing here just a simple SDI gateway into the 2110 world and then back out. So it's a little bit different. It's a full bandwidth. It's costly, et cetera. So that's what a lot of people think of when they think of 2110. But what we're seeing come out and start to be more prevalent is compressed. So with compressed, we're seeing TR-08, which is JPEG XS effectively. And we still have all of the different flows broken out separately. Big thing about 2110 is that it is dependent upon PTP. Without PTP, there is no 2110. So that's a very big significant portion of running a 2110 network is making sure it's all locked to PTP. Additionally, 2110 can be redundant, right? So -7 allows us to have two complete separate flows, allows us to do redundancy, which is a big thing and a big separator from some of the other sides of the fence that we're going to talk about here. But NMOS control is the key side of 2110. So most people think of 2110, that's about where they stop. But what we're seeing is a new feature coming out. It's not quite fully prevalent, but IPMX is starting to hit the streets. A lot of people are asking about IPMX, so IP Media Experience. This is leveraging 2110, so a lot of the same foundations that makes 2110 happen, but it's kind of aimed more at the AV side of things. It still uses NMOS control. It was drafted by the VSF, so there's a whole document series if you want to go read about this. But there's some constraints and options to actually make deployment easier. Namely, it can be deployed without PTP. So we can run asynchronous in this network. Makes it a whole different type of deployment. It's also, I kind of joke and called IPMX 2110 for HDMI. So it's not exactly right, but that's kind of like the idea behind IPMX, is that it's aimed at these HDMI display-centric applications. It also has a good security story there. But again, it is compressed, so we can use cheaper switches, right? A 10 gig switch is a heck of a lot cheaper than a 100 gig switch, right? Your optics are cheaper. Everything starts to go down when you get into the compressed world. So that's a little bit different than the 2110. Here's one everyone probably knows, NDI. Most prevalent IP transport in the market. It was designed as a low-cost, easy-to-use AV standard. It's pretty much everywhere. It was created by NewTek, now owned by VizRT, so it's its whole own division. Very broad adoption in the AV market, and we're starting to see it trickle into the broadcast market. Not necessarily for what's going to show up on air all the time, but used for maybe some smaller functions. 3 variants that we're seeing here, and we'll get into a little chart here in a bit that kind of defines these a little bit more, but basically you've got high bandwidth, HX2 and HX3 are your main codecs being used here. One of the lacking things of NDI is the control story. It doesn't really have a great control story. You're basically using NDI tools and whatever they provide you, and it is what it is. But they are working on ratifying some NMOS control that I read through a little bit, so there's a hope that we'll see it be able to sit underneath a larger control system one day. A little bit more into the variants here. In my PowerPoint, they all flew in nice and had animations, but we're using the PDF here, so we'll make do. Notice with the high bandwidth here, you got the 422 color space versus HX2 and 3 are 420, so something to consider if you ever think about using any of these variants. The latency is the big one as well. With high bandwidths, we're talking about 1 to 3 frames versus 100 to 200 milliseconds for HX2. Whereas HX3 kind of gives us a nice balance there. We're about 2 to 3-ish, 4-ish frames out, but much less on the bandwidth side, right? So bandwidth for high bandwidth, we're seeing 130 for HD up to 300 for UHD. Megabits per second versus very compressed for HX2 and kind of in the middle for HX3. So those are some of the differences between the 3 different variants there. Okay, Dante AV, who's seen this one before? We've heard of it. I've heard of it. I really haven't seen it, but we want to talk about it a little bit, just to kind of talk about the comparison here. So this is Dante for video at the end of the day. It uses Dante controller and domain manager. It was created by Audinate. And it's built on the broadly adopted Dante audio ecosystem. I'm sure lots of people use Dante audio, right? But not many people use Dante video. So I know that Dante wanted it to be something more than it is, but just not seeing the market-wide acceptance for it for whatever reason. There are 3 variants here, AVA, AVH, and AV Ultra, using different codecs accordingly. And we have another nice chart to go through those. So with, again, looking at the codecs, the color space is kind of the big thing that sticks out. With A, got your 422 and 444 using JPEG 2000 versus AV Ultra using JPEG XS and 422 and 444. Or the AVH gives us the much more compressed version. Latency is also a big deal, but we're seeing less than a frame for AVA. So very good speeds there, and up to about 6-ish, 7 frames on AVH. And then bandwidth, again, notice how much more bandwidth this is taking up. So again, you think about your switches, your whole network infrastructure when you're talking about all these different variants, right? So you're probably seeing a theme. There's a lot of things you have to weigh out when you start talking about IP transports, like how much compression am I going to give up? How big does my switch fabric need to be? What type of cabling do I need to use, right? What type of latency can I put up with? So these are all the types of questions as you're thinking about adding IP transports to your system, that you need to be thinking about and how they might affect what you're going to produce and what it might look like, et cetera. So So let's just compare NDI HX and AVH. These are kind of your simple bandwidth limited applications. So these are going to obviously have some sacrifices. HX and AVH are going to be compressed. Check out the latency, pretty similar on these two as well, but same codecs, H.264 high efficiency codec, and the 420 color space conversion there. And the big difference really in these is the acceptance, in my opinion. So ecosystem is what I'm talking about there. Very broad ecosystem for NDI. It's like almost not every manufacturer, but many manufacturers have an NDI supported solution, be it cameras, be it some type of recorder or playback. Just adding it into for graphics. You got graphics. You can put it on your computer and do all sorts of stuff. There's Zoom integration, right? Versus Dante AV. It's not really there, right? They want it to be there, but it's not. But they have a better control story. So it's just kind of funny how some of these on paper look really great, but in the real world, you see them just taking control a lot more. So NDI is by far the most popular IP transport out there. Now let's kind of take a step back and look at everything. These are kind of more of your live production type of applications here. So with high bandwidth is kind of on the lower end. If you look at kind of the bandwidth you have to do NDI high bandwidth versus on the higher end on the right for 2110, just look at those numbers, right? UHD 300 megabits per second versus UHD being 12 gigabits per second. So your switches, again, your optics, your cabling, all of that. Not to mention, this is typically going to be ×2. Right? Because you got a -7 network, so everything is twice as much if you want to be redundant. And typically, if you're setting up a 2110 system, you want to be redundant. But of course, in 2110, you're going to have a really good control story. There are numerous very high-end companies putting together control solutions that are quite incredible across the board. So some of my peer manufacturers make some really great ones. We have a decent one ourselves. So there's a lot of great control on the NMOS side of things versus on the lower end, when you look at NDI, again, it's more developing. So. When you think about any of this stuff, you really got to think about your network and the complexity therein. So on that first slide, or a couple slides ago, about the simple bandwidth, simple network, you're probably talking maybe a switch or two, max, right? Probably, honestly, a lot of those are just a single switch with a handful of PTZ cameras, maybe maybe an NDI capable switcher, some NDI graphics. It's all pretty plug and play. It just kind of plugs in and you're good to go. When you start getting into a larger system is where it starts to get really complex. And this goes back to like kind of the original start of, hey, do you have the staff to even support something like this if you want to roll out a big 2110 solution, for example? Typically in a 2110 solution, you're going to have network engineers who have been through intense training to be certified to be able to run Arista or Cisco level switches and get paid big bucks. And it's a whole different knowledge base than knowing how to terminate some BNCs and troubleshoot your standard, coax-based system. All sorts of consideration getting into multicast. There's all sorts of things you have to worry about there as far as using multiple switches, setting up your switches correctly, to talk correctly, all of the IGMP settings, etc. There's layer 2 versus layer 3 considerations. So you've got your switches, the more intense your network gets, the more expensive things get because your switches and your infrastructure start to grow. And then clocking. Again, like I said before, without PTP, there's no 2110. So you gotta have a really awesome master clock. You need to have all your switches being able to pass it. Versus on the other side, NDI, it's not required. They clock each other. So just you can see the complexity kind of goes from simple all the way to as complex as it can get. And we haven't even talked about wide area network and remote style. So let's get a little bit into that. So this is a little bit different than your NDI, your IPMX, and 2110, et cetera. This is more meant for transport from one place to another. It's designed to traverse unreliable networks, so there's ways to detect for lost data rates, retries, forward error correction, all of those things to make sure your signal gets from A to B and it has good integrity. So these are things part of these transports that are different than your NDI, your 2110, et cetera. much bigger emphasis on security since you're going across open networks, right? These can't just be in a closed network. This is oftentimes going on the internet, on the public network, and it needs to go from point A to point B, and it needs to not be able to get hacked. And then, of course, there's complex connection handshakes. So endpoints are typically independently managed. There's firewall issues you have to be able to deal with, and also the low latency. So these systems aren't really designed for low latency, but it is important to have low latency. But your threshold for latency is more. For instance, SRT, a half a second of delay is considered acceptable versus inner facility where that would just not even be a table stake, right? A half a second delay inside your facility wouldn't work at all. So we have 4 different types we'll touch on today. SRT, secure, reliable transport. RIST, reliable internet stream transport. WebRTC is web real-time communications. And then JXS or TR07. So a few different things to kind of categorize these. What I find interesting about the top 2 is they're, for all intents and purposes, pretty much the same, right? Like on paper, they look very identical. In fact, RIST actually looks even better on paper when you really get into it. But again, similar to NDI and Dante, acceptance and deployment methods, SRT is widely more popular. And it's curious because SRT was actually built by Haivision, so it was a private company that created this codec, or this transport, I should say. Ultimately turned it into something publicly available, whereas RIST was built by VSF. It was a group of engineers that came together with it. And again, on paper, it looks really great. But as far as deployment and acceptance goes, SRT is everywhere, whereas RIST is just not, and for whatever reason. Typically, SRT will be the one that we talk about a little bit when we get into some case studies, but we're talking RIMI workflows. So send your camera pack out into the world, send an SRT back to the control rooms. We're also talking about ground to cloud and cloud to ground workflows. So maybe I've got graphics in the cloud. Maybe I've got a switcher in the cloud. I just take cameras somewhere and send them up SRT, convert them to NDI, and run whatever switcher and graphics applications and playbacks. Do a whole system in the cloud, but SRT is typically your way of getting up there. WebRTC, typically more of like a very low latency return feed, it's typically used for video conferencing, but you're also seeing it for return feed multi-viewers because it's such a low latency codec. JXS, starting to see that more and more. Similar functionality to SRT and RIST, but generally speaking, higher bandwidth needed for those. So that's what we're seeing there. So let's get into just a couple use cases, right? So let's just talk about our good old SDI. When are we still using SDI? So some of this is my opinion. You may or may not agree. But typically, if you're talking about a router matrix size of 300-ish or less, and it's going to be a centralized deployment, meaning you're not really going to have it spread out over multiple campuses. You still have a lot of legacy SDI equipment. You don't really plan on expanding anytime in the near future or maybe ever. And definitely on smaller deployments, SDI is still making a lot of sense, and budget constraints. If I don't have the money or the staff to support this, then SDI sure seems like a good ticket for me. So as a couple examples, maybe a small system for a house of worship or a school, right? So you can see this is a pretty basic system, a couple cameras, a switcher, some graphics from ProPresenter, et cetera. So very simple, no real need to go crazy with 2110 for a system like this, for example. Borderline maybe NDI level here, right? Another example, maybe a small school or just a school, some type of educational system. So, we've got editing, we've got graphics. Again, pretty localized, fairly small footprint, not getting too crazy with it. There may be some need to bring in some hybrid IP here, but again, SDI works perfectly great for a system like this. This could be a fly pack too, something mobile, right? So this is an example of like a mobile configuration. So a centralized small form factor router, right? Up to about 160 square. You got multiple channels of graphics. You've got a Dante audio system here. replay, etc. Again, this can all fit in a fly pack or two, and is very purpose built. Not a really great reason to go to IP transports for something like this. And lastly, like another education. Oh, this looks like the same one that I put in the other one. Sorry. So NDI. When do I put in NDI? Right. So these are a couple, again, my opinions here. Existing CADX ARC infrastructure. If maybe I'm a corporation and I've got CADX plumbed everywhere in all my rooms. Why go pull a bunch of coax now? I can just run NDI cable or NDI cameras and NDI capable switchers and graphics, and everything's already ready to go. Maybe I already own a bunch of NDI capable devices, and if my budget's fairly small, NDI makes a lot of sense here. So a small couple of cameras, a small Ultrix, for example, Expression, all of these are NDI native devices. So I can put these things fairly quickly together on an infrastructure that's already in place, and in short order have a working system. So SRT, I mentioned this a little bit ago. REMI productions are a huge use of SRTs, probably the #1 use that I'm seeing out in the field. Remote contributions, so maybe I send some people out in the field to just send back a camera or two, and the ground to cloud and cloud to ground story is SRT for us. So studio to stadium, right? Send out my cameras, convert them to SRT, take them back to the control room, and convert it back to baseband, and off I go. Or maybe I have a production facility somewhere and I want to work from home, so I can send SRT home. Sure, that's a way as well. And then you can see here the cloud solution as well. I can send my cameras into my stadium or my studio or wherever it may be, and convert that to SRT and do all the switching and graphics and everything natively in the cloud. We're seeing people go that route, right? There's a whole other presentation that can be done on cloud workflows and the benefits and or issues that come with that. And last but not least, 2110. So these are, in my opinion, for large-scale deployments, right? So who knows how big this router matrix can get? And when we talk about router now, we're talking about our switch fabric. We're not talking about a physical, 5 by 512 by 512 router or 1024 by 1024 router. We're talking about switches deployed across the campus or building, or levels in a building, stories in a building. A constant need to grow is a great reason for 2110. We don't know how big this system is going to get. I may be adding a campus and adding a whole other contribution network over here that I need to plan for that may or may not come. So it could come one day in a distribution, right? So this is going to be like, I have a control room centralized here, but then I've got a studio on this building on the campus, another building over here. We're building things all the time. These are for larger scale deployments, right? That's the big thing to think about when you think about 2110, in my opinion. I hear some people come to me and they say, hey, we want to go 2110, and I'll say, well, why? And they say, well, it's the new thing. And it's not even that new, right? It's been around for 10 years, but everyone thinks I got to go 2110 because it's the new thing. That's fine, but I start asking questions about this, right? If we're talking about a 300 by 300 router, and you're 1 or 2 control rooms, it sounds like you just want to go to 2110 to go to 2110. That's not to disparage 2110. 2110 is here. It's great for a lot of things, but in my opinion, these are some of the check boxes that I want to see checked before I start, recommending people go to 2110, because it's expensive. Like I said, it requires specialized skill, network engineering skills that are different than broadcast engineering skills. There's things you got to think about as far as troubleshooting. I can't put a cable into a patch pane and put a waveform monitor on it anymore, right? I need to have special monitoring tools to look at packets now. I'm not looking at data streams, I'm looking at packets. So it's a whole different subset. There's nothing wrong with that. But again, in my opinion, you need to start thinking about what boxes do I need to check to really make this make sense for me to go to 2110. So this is an example of something where it might make sense, right? I've got multiple PCRs, I've got a master control, I've got multiple studios, I've even got a mobile kit that I'm going to roll in and out occasionally. So, right, we're checking a lot of boxes here. This is a large-scale system. This is deployed across multiple areas, right? This might add another studio one day. This might add another control room one day. So, kind of getting the big picture of like, hey, this starts to make sense for 2110. I don't recommend people just get into 2110 because it's the shiny new thing. And again, it's not a shiny new thing. It's been around for about 10 years, but there's a reason why SDI is still here, because it just works in certain situations. And there's a reason why NDI is here, because it works in certain situations. So that's kind of the general theme of my the presentation so far. So another just kind of similar idea here, just centralized system core on network switches. The switches can be distributed around, et cetera, but lots of different event spaces or control rooms and production studios, et cetera, spread out, growing, lots of flexibility. So let's see, and this is just kind of a mix of everything. So that's another story, right? So sometimes maybe I want to have a lot of SDI, but I need to add a little bit of something else, right? Maybe a little bit of NDI, maybe a little bit of MADI or Dante, or some of it's fiber, or maybe I need to interface with a little bit of 2110. So there's always a solution for everything. The point of my presentation today is there's good reasons to do any number of these, but be thoughtful about how you go about planning out your system and how you move forward. Just a final graphic kind of showing everybody working together in a happy little system here. We have written a couple of papers at Ross, so here's a couple of QR codes for you guys. So we've just released the one on the left side here as of last week. I invite you guys to go check that out. It's just talking about similar concepts that I just spoke on. And this is a little bit of one that we put out last year, a little bit older one. Kind of talks about more detail. It's more of a chart-based view of all the different IP transports that I talked about and some more. So that's got a lot of good information there. So hopefully everyone's got a link to those. They're on our website as well, rossvideo.com, so please help yourself there. And last but not least, this is my information. If you care to reach out to me, that QR code will take you to an Outlook or an email to send me to an email. So yeah, any questions on any of that stuff? I just blew through a whole bunch of information and probably a little bit faster than I really intended to, but yeah, not bad. Yeah, not bad. So. Yeah, I'll give you a second to digest, but if there's any questions, I'm here to answer them. I guess I got a half hour. Yes, go ahead.
Do you think that the switch manufacturers, Cisco and stuff, will ever lean a little bit towards the video aspect of it, of multicast, and specialize in any of that? Or are we kind of just waiting to get on board with Cisco and all of them to make the NDI, the SRT, and all that stuff work?
It's my personal opinion. I think they're not going to really bend to us. We're only a small slice of their market. I think we're using their tools in our playground. They're not coming to our sandbox to play. We're stealing sand out of theirs to make our own sandbox. So I think that's kind of why I was going back to like network engineering being such a huge critical piece to this, is having someone who understands that and that can manage that. And I think a lot of people remember when it was the broadcast engineers battling with IT engineers, right? Like you never want your broadcast stuff touching the IT network because they're going to push out an update at like 10:59, right? And then boom, we're off air, right? For the 11 o'clock newscast, like who pushed out the Windows update, right? Like, come on, that's changing. Like there's a little bit of symbiosis between broadcast and IT guys. That's going to have to keep getting more tight.
It just seems like even with the multicast, like you always have to have separate switches for everything, just because you don't want the you plugged into the wrong port and now your entire system's hosed because of a multicast.
Yeah.
I think Netgear Enterprise has some NDI enhanced.
They do, yeah.
There's some plugins for it. They have some NDI services in the Netgear Enterprise routers if you want to go that way. And as far as multicast, as long as you're VLANing them and they're different VLAN, that's how you deal with multicast, not going over into your unicast network.
They are getting they're also deploying the 2110 switch as well. We haven't had a chance to test it yet, so we'll see how that plays out. Right now, we mostly test with Cisco and Arista, to some degree NVIDIA. But those are the big boys, and they're so expensive. It's super expensive. And
the Nexus switch is about, for Cisco, the Nexus switch Cisco.
Yeah,
That switch is,
yeah,
that's gonna do it, but it's,
right,
it's like, whoa.
yeah, yeah,
Even Juniper and Juniper on their high end.
yeah.
But again, you're talking very expensive.
Enterprise.
Yeah.
Exactly.
Oh,
And
yeah.
when you're talking uncompressed 2110, that's that's what I was kind of at the start of it. We got into the compressed. Like I think IPMX and the compressed side of things will help a lot with this, but IPMX is not a deployed standard. There's a lot of people talking about it, but it's all talk right now.
These routers
So
have to have a big enough backplane so they can't oversubscribe them.
exactly.
And cheap switches that you might have bought in the past aren't gonna do it.
Or you're getting into orchestration, and then you're like saying, okay, well this can get through, but that can't. And it just becomes this complex thing versus like having an all-in-one frame of a router of 576 by 576 or whatever it is. You just know like. I mean, I can send that one route to 576 outputs all day if I wanted to, and you don't think about that, right? So it's the IP side of things. I mean, it's here to stay. It ain't going anywhere for sure. But one of the things I was trying to get across today is like, there's still a lot of good tools in the bag that are tried and true, but they can mix in with all the other things that we're playing with today. So, any other questions? Cool. Well, I gave you back some time. You can go walk around the floor. Thanks so much for your time. Appreciate everybody.
Hey, Joe, I just wanted to say hi.
Hey, oh, what's up, man? How are you? Good to see you.
Real important.